Today's topic, we're talking about persistence of data in Flutter. So persistence is just basically having the data stored locally. That, okay, we can have persistence on a remote server or we can have it locally persisted. So we're talking about persisting the data locally in Flutter. So why would you need to do that? So number one, we may need to store user data. For example, their username and their preferences, and basically, for example, let's take an example of, say, if you have every time you're opening the app again, it doesn't ask you to log in because it has stored all the information that you have locally, and you don't have to be also online. So once you just open the app, you are there. It wouldn't be a very good experience if every time you are coming into the app, you have to log in first, and you have to wait a few seconds for it to get all the information. All you just need to do is maybe see your feed, and your feed, maybe you'll need internet for that. But how about your username, your photo, your everything that belongs to you? There's no need for it to be. Obviously, we will have copies on the Facebook servers, but we also maintain local copies so that the experience becomes better. And that is how you may see it. That makes the experience so much better compared to an app where you would have to open first time you log in, it starts fetching information before now you start using the app. Another use is caching data. Let's say, for example, you're making requests to the server, and those requests are not changing so much. So if they're not changing so much, there may be a need to cache, because let's say you have slow internet and you need to access that data, and it's not changing so much on the server by itself. So there's no need for it to be fetched every time. So the app may just cache the requests, and then every time you open, you get it even faster. Like, it takes, instead of taking an extra 1-2 seconds for it to fetch the data from the server, you open the app and the information is there already. So another use is basically making an offline app or offline fast apps. So an app where, let's say, for example, let's take the example of a password manager. This is something that you want the user to have the data locally every time, so that they can fetch, get their passwords, and log into other services. So there's no need for all this data being just persisted on the server and you don't have them locally. Let's say you want to log into another service, you have to wait a few seconds for it to fetch the data, then you can use. Also, another example is apps that are used in remote regions with intermittent internet. So you may want to, let's say, for example, the user to enter all the information, then it will do the syncing when the user gets information, gets internet, sorry. So when they get internet, then the data will be synced. But you can just be able to, maybe when they fill forms, for example, they are saved in local storage, and when now internet is detected by your app, then it will just synchronize. That makes it easy for someone who is living in remote places, let's say in northern Kenya, where like there's problems with internet, and you're not assured of having internet every time, and maybe just in specific hotspots you'll have very good internet, and then you go away from them, you can't access everything. So if you want your user who is using your app in such a region to have a very good experience, you may want to cache the data locally, save some data locally, so that they can basically be able to use that information. So how do I save data locally? So number one, there's the issue of there are several ways of actually saving the data locally. You can save in a KeyValue store, which is just a simple, it's not as complicated as a database, but it's just a database that saves a key and a value, and it's not very complex, not used to store very complex information. Another thing is that you can also use local files. So you can store data in a file, and basically be able to fetch it from that file and use that information. You can use an SQL database. There are SQL databases for mobile apps that you can use instead of using these server-side databases like MySQL, Oracle, MS SQL. They are very small SQL databases that you can basically be used. You can use locally on your app. There are also NoSQL databases that you can use. This is the databases that are used for complex information. If you have information with complex structure. So KeyValue stores. So what's a KeyValue stores? It's just a database kinda that will store simple data. Let's say, for example, you're storing someone's name. You're storing just as a string. You're storing their email address. You're storing their gender and whatnot. So instead of saving all that information in a complicated database, you may just want to fetch. And let's say a good example is a token. You don't want to store a token in a very complex DB where you will need like some work to be done before you fetch it. Just may need a very simple key value store to fetch the information. So it's very useful for storing app preferences for the user, keys and tokens and session information basically for that specific user. So you just cache the information in that key value store, and then when they start the app, that's where you fetch from instead of fetching it from the server. So a very good example is shared preferences. There's a package called shared preferences. It's a plugin called shared preferences in pub.dev that uses iOS default preferences and other different default preference libraries to store their data. So this is just an abstraction of this specific. In iOS, we have NS user defaults, and in Android, you have shared preferences. So the shared preferences, that library is just an abstraction of those two, and it will fetch, depending on which platform you're on, it will just use the default key value stored for that specific platform. So we can also store data in local files. Any extension, you can just store the files as long as your app can read the extension and be able to interpret the information. You can store, let's say, a text file with the information that the user wants. Even a key value store, you can develop a key value store in a local file and then fetch it from there. So usually an app is usually given an application specific directory where all files can be stored. So that place is not accessible by any other, that directory is not accessible by any other app, it's just accessed by the app you develop. So instead, when you decide to store your information in a local file, it will only belong to that app. So this is used mostly, let's say, for example, you want to store some blob data or do file caching. So caching requests in a file, you can do that using a local files. We will see about how to use them in an example that we have that will do a demo. And then we have SQL databases. So an SQL database, if you are comfortable with SQL manipulation, it's a very powerful tool that you can use to store complex relational data in tables so that your application can be able to access that data. Remember again that database is only accessible by your application. It will not be accessible by other applications. So you can store the data in confidence, knowing that this data is only accessed by my app and it won't be accessed by another app. So another advantage of SQL databases is that they are usually written in maybe low-level languages, so their speed is very fast in accessing the information. So that's one advantage of having an SQL database, a very complex data set. You can store a very complex data set. You can also take advantage of the speed that it will give you to access the data. So the most common SQL database actually is SQLite or SQLite. I don't know how people pronounce it. So SQLite is the most common one, and it stores its data. The advantage of it is that it stores its data in just a single file, and you can do all the data manipulation using SQLite, using SQL language, but it's just fetching data from that single database file. So remember, we said that the data file is shared, is only accessible by the app, by your app only. And then usually, in most cases, you wouldn't want to write raw SQL data queries in your app on the client side of your app. So you can use an ORM. There are so many ORMs out there. So we have in Flutter, we have one of the most common ones is Moor, which is just a play on the word room, which is room is the SQL ORM for Android. So Moor is just something similar to that. So there are also NoSQL databases if you are storing something that is unstructured. Remember, we say that SQL is for structured data, basically relational data. How about if you want your data? How about if your data is unstructured? Basically, the structure of the data is not well defined, so you may choose to go with the NoSQL database for storage of such information. The advantage is that it's very developer friendly compared to SQL, because SQL needs prior knowledge of the SQL language to query, or rather you will have to choose an ORM and work with it. So NoSQL is usually very easy, and examples include Hive, Sembast, and ObjectDB. You can find all these libraries in pub.dev, and those are the most common ones according to what I've seen. So finally, before today's topic is actually just very short. So there are things to note when storing data locally. Number one is that you can use any. You don't have to use SQL, NoSQL, or key-value pair local storage. You can use any. You can store your data in any format that you want, but always remember to choose the optimal solution for that specific thing that you want to store. That's why we used the examples, and we said key-value stores are good for storing preferences, tokens, and whatnot, because they are easy to save and fetch. But you don't have to only use that. You can use SQL, you can use NoSQL, you can store your token in a file. That is okay. So one other thing that to note is that this data that you're storing on your mobile app can always be deleted by the user. Let's say, for example, in Android, when you go to storage and go to maybe the storage information of a specific app, you can be able to delete everything. So this will delete all the information that you've stored in that specific app, in that specific app. And also, if the user uninstalls the app, all the data is wiped. So remember that while you are doing it, because you may think about maybe having data stored locally as a backup or as a convenience way of the user using your app, but not just to save all information that is very critical to the app inside the app, because it can be easily deleted. The best way is maybe to save it there and basically be able to synchronize with your backend server, so that the data is backed up. There is backed up in your app, but it's the main true copy is in your server. So finally, we have the final note that I have here is that when pushing an update to the app, let's say, for example, you have developed a very complex SQL database. Now, when you push an update that will include new fields, let's say if you have a table with specific columns, let's say you're adding another column, remember that always in that update, you have to update that database. Otherwise, the data will be inconsistent. You'll be trying to fetch information from a table which doesn't have a given column, and the app will crash. Users will start having problems. So especially in SQL or in SQLite, always you always have to handle migration of data structures in case there are changes between one version of your app and the next version. That's why it's good to use something like, that's why it's good to use an ORM. ORM will manage that for you so that you don't have to manage that by hand. So those are the things to note when just storing data locally. In case, do we have any question before we go to the demo? Candy, welcome. Do you have a question?
Hey Danvik, thanks for the welcome. Yeah, I have a question.
Yeah.
So it's a very stupid question because yeah. So
There's
let's
no
say
question.
Unona,
Mhm.
like how we were using block
Yeah.
and then we're using Cubit. Uh,
Yes.
there's a way you like, let's say on a form, and then
Mhm.
let's say you go to the next page and then you come back to the previous page,
Mhm.
and you see like everything that you'd already keyed in that particular form. Alafu,
Yeah.
let's say you want to review whatever, you have a button that you want to review before,
Mhm.
let's say you submit your form.
Okay.
Does that apply as localization? Sikuelewa hiyo bit.
Okay, so you're mentioning a very different topic. Localization is different from storing data locally. Localization is actually internationalization of the app. Maybe someone who is using it in France gets French. So
Oh,
localization is a bit different from storing local data persistence.
oh,
So
hmm,
well, in that case, I would advise that you store your data locally. You may have something like Hive or shared preferences. Or shared preferences would not be good for that since it's a key value pair. But
hmm,
maybe think about something like Hive or
mm-hmm,
SameBurst, where you will store that data locally, and then you'll fetch it whenever you need. Another option is to use, if you're using block, then the best option would be to use hydrated block or hydrated qubit,
yeah.
which will handle all that storage for you in the back of your app.
Mm-hmm.
And then when you come back,
Mm.
it's just saved automatic. You'll come back and find it there. So I think you are the best audience for this because I have an example for that.
Okay.
So yeah, let's just go to the demo and then you'll be able to see that what we have there.
Okay, cool.
Okay. So here we have a very simple app. I didn't think it would be necessary or it would be easy or fast enough for us to develop this app from scratch. So what I did is I just prepared some information, I prepared the code before, so we're just going to mostly review the code and see how we achieved whatever we achieved. So this is a very simple app that it is an offline only app that someone can be able to maybe write an article, do something, and then when they come back to the app, let's say I do close my app, and then I come back. Okay, I haven't said that. I come back to my app. I can be able to see the information that I had saved initially. So let's say, for example, I modify this this file. Let's say, for example, let me just do that, and then I save, and it has been saved. So what I can do is that let me say I want to quit the app, and then open the app again. See if we have that same information there, and we can see that it's there. So I've tried to use two options that we have. Remember that we said there are around 4 options to use. So there is key value pairs. There is NoSQL databases. There is SQL databases and there's local file storage. So I've used local file storage and shared preferences as our key value pair. So we will do an example of that. And in case you want to go further into this, maybe you can have a look at SQLite or Room in Android or more in Flutter. So another thing that we've also done is that we have here our profile. The user can edit the information, and so this here we are using this article of ours is stored in a text file. So a very simple text file, you can write an article and save it there. And for these other options where I can store my profile, we are using a key value pair, which will store the name and the email separately, and then we will just be able to fetch it. And then finally, we have a preferences page that will use basically just to save our information, and it will use here we've used a topic that we covered before, that is state management, and we've also used a file storage to store the status of our file, basically the status of our app. And remember that let's say we were in dark mode, if I do light mode, and then just completely quit the app and then come back and open again, we see that we are in light mode. And if I change back to dark theme and then again close the app and I open again, when I open, since since we have stored this locally, the app will remember that we are in dark mode. So this is a very good application for storing your data locally, especially with a key value pair or on a file, because the user has already selected their options for how they want their app to look like. So you don't want to, let's say, for example, if you store that information in a file, let's say, okay, not in a file, but let's say in your server, basically say user X has chosen to use dark mode. So the next time they open the app, so maybe the default one is light. So the user will see the light mode, and then it will go and fetch that preference from your server. That will take a few seconds at least, or a few milliseconds before the app now becomes dark mode. That is not something that you would want. You'd want your user to have the information, their preferences stored locally, so that they keep that experience that they are used to or they like in the app. So for the example of storing this article of ours that we are writing, maybe we are thinking of a new article, we are writing it as we go. Maybe I'm on a bus, I remember something, let me just come and add and modify this article and continue writing it when I have my free time. Then when I close the app, I save it, and then next time I'll continue. So this is a very good example for that. So what we've done here is that in our init set for the app, for this page, the home page, first of all, we try to get the information from we can read the content of that file. So this function, so we have, let me just go through the functions. So first of all, remember we say that an app will be given its own directory for storing its information. So there's this function that gets the directory for this specific app. So this is how you get it. The function is called get application documents directory. So this specifically belongs to this application. So I can get that path of the directory, and then create a file in that directory. So our local file is just that path for the directory, that path for the directory for this app, and then we have data.txt, which is where this data is stored. So we have a function to read the file. So it will just get the file and read the contents. So it will read the content as string, and then it will return the contents. Then we have another function that, given a string, it will just be able to write the content to that, the string to that file. So in our app, first of all, in our init state, we are reading the contents of that app, of that file, and when the reading is successful, basically we just store the contents of that file in our data. We have a string here called data, so we just save it there. In case we have an error, we can just ignore and assume that there is no file, because the file cannot be there, will not be there in the first instance when the user runs the app. It will need to be created, so we can just ignore that error. And when it's complete, we want to this is just a simple way we want to get a text editing controller, so that when someone edits here, it updates our app, our data variable. And finally, when the user clicks save, it will go and write the content. So here we have our text field here that we can be able to edit. And when we click the button, basically what it just does is that it will get that data that someone has written and then save it directly. And then basically it just notify you that, let me just, this. So my article has been saved. So this is the way you'd go about it. So in case there's an error of saving, maybe just let the user know an error. That's why we've used a try catch here, so that you can just know whether the information is saved or not. So the next time the user will come again, open the app, remember that it will go to the init state, read the information and save it in data. And basically what we are doing there is that we are just setting the text file to have our text field. Using this context controller, we are setting the text of that field to be the data that has been fetched from our file. And from that, we can just be able to save the file and be able to update it when we need. And then next time we come and open the app again, we have the contents that we were, the information that we were saving there. So another example, now this is using file storage. This is just simple file storage in a text file. And then we have another example here for the profile. We're using shared preferences. So shared preferences is a key value store, sorry, which stores key value pairs. So that's where the confusion is coming from. So we have here, so shared preferences is you'll have to bring it in as a dependency in your app. Then after you bring it in, you can just be able to, in our init state, we have this function called init data. So init data will just initialize the data from the store. In case the user has saved their name and email there, then we'll be able to fetch. So what we do is that number one, in our init data, we just initialize our shared preferences by getting the instance of shared preference, and then set the name to be the name that has been stored in our shared preferences. Remember that a key value pair means that the data is stored. You'll have to specify a key and set the key of that value. So the key in our instance, you can take it as an example, as let's say a JSON object which has key and value. So in our case here, we have a key named name, and we have another key for email. So using that key, we can fetch the contents of that key and save them in our email, then fetch the contents of our name key and save it in our name variable here. And then what you can do using remember again our text editing controller. So usually a text field has a controller that you can use. So we're just using that controller to set the name. And if there's no name, then you can just set it as empty. And then we have an email controller, which will set the email field. Again, we can be able to edit. Let's say, for example, here I have a very long email. So let's say I have my name, let's say my email is done@gmail.com, and my user is done. So I just save, and we have here a snack bar that just notifies us that the information is saved. And once it's saved, if I quit the app and come back again, it will have saved, because we have here in our save button, we are again getting the instance of our shared preferences. And now instead of getting string, we are setting a string. So inside the same, remember, it's the same key here. For name, we have the same key, and it's case sensitive, so you'll have to have it in the same way. In a production app, you may have it as a variable somewhere, so you just reference it so that you don't have typos and basically try to fetch information from a key that doesn't exist. So here we're setting the name and the email in the key, name and email. So set string expects two parameters. The first parameter is the key, and the next parameter is the value. So our key value store. So email, that's how you save, and then you just tell the user that it has been saved. So when we remember, we have updated this. Now when we go and quit the app and then come back again, open our preferences, our profile, the information has been persisted and it has been fetched successfully. So finally, for Candy's case, we are using hydrated block. So remember, we talked about in our last session, we talked about set management. So block is one of the set management options that you have in Flutter. So this is how you bring it in. You bring in Flutter block, which is the set management library, and hydrated block is just an extension of that library that will do this for you automatically. When you change, let's say, for example, we are using this here in our preferences. So when you change the theme, what this will do for us is that it will save our preferred theme in a local file, and that will be fetched next time, so that when the user downloads the app, opens the app again, sorry, we are just fetching from that specific file that we stored. So Candy, here we have we've included these two. Then for hydrated block, you need to set how you're going to store your app, how you're going to store your data. So for us, we're just storing it in a file in our directory. So we are just getting a temporary directory and storing it there. So in this case, maybe we would have used stored it in our application directory instead of a temporary directory, which can be lost anytime. So you can just store it in our application document directory. This is just the setup, and then finally we are also providing that theme, so that we are providing that Cubit so that it can be able to be accessed from anywhere. Let's have a look at the Cubit first. So this is how our theme Cubit looks like. So we have our hydrated Cubit. Remember, it's not just a Cubit, it's hydrated. Hydrated just means that it will be saved and fetched from a file or from persistent storage, any persistent storage. So be it in our SQLite key value pair or file. But for us, we have chosen the option of storing in a file. So the rest of how it's going to fetch and get hydrated Cubit will handle that for us. What we have here is that we are setting our default theme to be light. Then we have a function here called toggle brightness. So in case the state is light, then we save it as dark. In case it's dark, then we save it as light. Just as simple as that. Then the most important bit in hydrated Cubit is having basically what it does is that it serves in a JSON format using JSON is very similar to that map. So what we will do here is that we will save this this information in a JSON key. So let's just do, in fact, let me, for ease of understanding, let me just move this here, because first of all, we need to understand how it writes. So through JSON, we basically just we are just creating a map here that will save the information in the form of a string. So we are just converting the light or dark in the form of a string, so that we can show it in a file. Because I'm sure a file will not understand what this specific class or this specific enum in that what it means, but we're just converting it to a string and then saving it as a map with a string. And then when the app starts, it will first of all try to read from the file for using this function. And then when we save, anytime we change the theme, it will just go and save to a file using this function. It will basically convert it to a JSON file, to a JSON object, and then save that object as a string. And then when we start the app, it will be reading from that same string. So that's how we are doing it. And when we go to our preferences page, you can see that we are using block builder. So for anyone who understands block, this is just a function that will build your widget depending on whichever state it is. So here we have a list style with a switch, and we have it named dark theme. So if the state is dark, then the switch is true, and when we basically flip it, it becomes false, and then the theme will also change. So that's as simple as it is. And then finally, when the data changes, basically when the user taps on the icon, we can just call our toggle brightness function. So that is basically how we do it. And once we do this, once we save the app in dark mode, once we save the theme as dark mode, it will just persist to file, and when we start the app, it will again boot from there. So Candy, in your case, you would get that whole information in form of, maybe you can create a data file, a data class, which will have all that information. Let's say, for example, we have let me see, we can just build one simple one. Let's say, for example, we are building an app that has a form, in your case, a form that will have a given number of fields. You can say, let's say, for example, field 1 and 2 are set in the first form. Let's say, for example, we have, let me just do a very quick data class here. So let's take the example of a contact and create a class contact here. Let's say, for example, a contact has a name, is a string, make it nullable. Let's say first name. Let's just duplicate that file first. First name. Let's say you have a date of birth here as a string, or let's start with email. Gender. Then we have DOB for date of birth. So in this case, we may just consider using it, creating a function called, like just the same way we had it here. You can just create a function that converts it to a JSON and back. So in this case, let's assume that in your case, Candy, you're building an app that maybe it will ask for the name. Let's go back to our contact here. Let's say it will ask for the name, first name and last name in the first page, and then ask for the email and gender in the next page. Is that the case, Candy?
Yeah, that's the case.
So let's, yeah, okay.
Mhm.
So let's assume that we have first name and last name as asked in the first page, and then email, gender, and DOB are asked in the next page. So you can just first of all create, in fact, for the sake of time, I'll just copy this. And save it here. So here to JSON, we'll take contact. We can just make this start. You can also just make this static. So it's supposed to return a contact. Let's say, yeah, let's use dynamic instead of. So first of all, here we'll just given a contact. I'm sure you know how to do this, so I'm just going very fast, very fast. So just replace here very fast. Nothing. And replace this. Nothing. Okay. So you can just say we have a function that will convert the whole class into a JSON. So it will just be contract. The reason why you have to convert into JSON is because JSON is very easily saved as a string. So that means that we can just save in even a normal text field, right? So okay, I think I have last name missing here. And then we can get contact from. So in this case, given this, we can just return contact. Okay, we need to generate our constructor. Can just again replace that with this and string. This. So you have our constructor there, and we can just now construct a new class from this JSON file. I'm going to replace that with a column. Yeah. Then let's replace this with that. So given that we have now a way to convert from given that we have a way now to convert our class of contact from a JSON and back, then we can just generate our Cubit here. New. We are so off topic here, but we can go fast. Name it contact Cubit. Make sure it extends hydrated Cubit. Or let's say, for example, if you're using block instead of Cubit, you can just do the vice versa. Use hydrated Cubit instead of hydrated block. Then we need to generate our overrides here. And then in this case, we will just return contact dot JSON. Just that. Then to JSON, we just use that to convert our contact. JSON. Our state is the contact. So Candy, what you can do then here is that you can have a function. Let's say by default it's just a normal contact with nothing. So here we can just have a function that will update the contact. And then which will emit so in this case, this is how you do it. Let's say, for example, in the first page, you will just have use your normal block builder to get the initial contact information. Let's say the way we did it here. Sorry, not there, but in preferences, maybe after providing that hydrated Cubit in the app, you can just create another builder here, and in the first form, you update the first name and last name, and then save by calling that function that will, when someone goes next, you save that by just updating the contact. And then when you go to the next page, you'll find that instead of saving it instead of losing that information, when you go back, you will find that since you are referring to the same contact object in your Cubit, then when you go back, you'll find it there. I don't know whether you're getting my point.
Yeah, you've actually answered what I wanted, because I wanted to like clarify it in my coming blog, but then yeah, you've actually clarified what I wanted to know, especially that the qubit bit.
Okay.
Yeah, thank
So,
you.
any other question?
Not any other question. I feel like using MySQL. I'm sorry I joined a bit late. It looks like you're writing less code compared to using the block.
Using which? Can you repeat the statement?
I'm saying,
Mhm.
I don't know if you had already written a bit of code before, but it feels like using block you write more code compared to the other. I
Qubit.
forgot the name. Yeah.
Yeah, Qubit is usually it's an easier way of working with it, but there are cases where you need block and Qubit will not work for you, especially if you want to keep track of the changes.
Yeah, makes sense.
Yeah, so you can intercept those changes very easily in
Okay, cool.
in
Thank you.
block.
Thank you so much.
Okay. Is there any other question from anyone else, or should we stop here?
Mm, from
Okay.
my end, no other question. Oh, it's
Okay.
just three of us.
I see. I see. So I think we will stop there. I think
Mhm.
we'll just let Ivy know, and then we can stop there.
Okay. Quick one. Have you, this recording will be posted on their YouTube channel.
Sure, sure. Ivy is in charge of doing that, so she will. I'll also share the the, the
The
slides that
code.
I was using so that you can refer in case you need any clarification.
Yes, please. Yes, I would need it.
Okay then.
Okay. Thank you. Thank you so much, Danvik.
Thank you. Have a good evening.
Okay. Good evening too.
Okay. Virginia, have a good evening too. I think that is the end of my presentation. I will
Mm.
end there.
All right. Cool. Thank you.